Alright guys, a funny story. I recorded the video, but I forgot to record the audio, so it's just a video of me writing things and not saying anything. So here's number two. You'll get the video a little bit later than I expected. So question one, Alama writes two rules on the board. Rule X, add 3 and the starting number is 0. Rule Y, add 15 and the starting number is 0. Which ordered pair fits the rule? And it says to make a table. The table's already set up for us, but like I said before, I like setting up my tables horizontally because it's a little easier to just look at it for me. You can also use this strategy as well. So we have 0 that starts for x and y for every, so this is the first term at 0, 0. The second term is going to have 3 more because our rule is going to be plus 3 for x and plus 15 for y. So the second term for y will have 15. The next term, it'll be 3 more for x and then 15 more for y, 3 more for x, 15 more for y, 3 more for x, 15 more for y, and then 3 more for x, 15 more for y. So we see here that we've made a bunch of ordered pairs. We have 0, 0. We have 3, 15. We have 6, 30. 9, 45. 12, 60. And I'm going to go check my answers and see if any of those ordered pairs fit these rules. So we have 0, 0, which is not one of our choices. We have 3, 15, which is still not a choice. 6, 30, also not a choice. 9, 45, also not a choice. And 12, 60, also not a choice. At this point, I need to think to myself, did I make a mistake somewhere in my addition? I didn't. So I'm going to go ahead and keep checking and keep going on with my pattern. So let's go for 1890. Sorry, I forgot to write 1575, which is also not a choice. But I do see that after I added 1890, that is an answer choice. So my answer is going to be 1890 as the ordered pair that fits this pattern. Question 2. What is the rule for the table and plotted points below? How do you get from x to y? So if I write out my x and y, I can figure out the pattern. So our first one is going to be at 1, 4. So x is 1 while y is 4. And then our next one's going to be 2, 8. And then our next one's going to be 3, 12. And then it's going to be 4, 16. So we made the ordered pair of 1, 4, 2, 8, 3, 12, and 4, 16. So I'm going to scroll down and see that we were already given the table, but I want to always make sure I'm practicing making the table based on the graph. And we can go down here. So they're asking us to figure out what's the rule. Multiply x by 4 to get y. Well, if I'm going from x to y, it's going to be x 1 to 4, or 2 to 8, or 3 to 12, 4 to 16. And to get from 1 to 4, I know plus 3 works, and so does times 4. So one of those is going to work. And then if you try the plus 3 rule for 2 to 8, if you try plus 3, 2 plus 3 is only 5. So I know the plus 3 rule is wrong. But the times 4 rule will work because 1 times 4 is 4. 2 times 4 is 8. So I know that I have to multiply x by 4 to get y. And there is an answer choice that tells me that. Multiply x by 4 to get y. We want to make sure that the rest of them are completely wrong before we go ahead and click that one. If we multiply x by 2 to get y, do we get 4? So 1 times 2 will not be 4. So we know that rule doesn't work. Add 4 to x to get y. So x plus 4 is going to be 1 plus 4, which is 5, which is not the y value we have. So we know that's wrong. Add 2 to x to get y also won't work because 1 plus 2 is only 3, and that's not the 4. So we know that this choice we had before is the absolute correct one. Question 3. We have each classroom in a middle school has 20 farting llamas as shown in the table. Which ordered pair follows the rule in the table? Well, first of all, let's determine what our rules are. So we want to go from number of classrooms to number of farting llamas. And this is going to be our x value, and these are going to be our y values. So to go from x to y, we need to figure out how we can go from 1 to 20. And in order for us to go from 1 to 20, I can do plus 19 or times 20. It might be a two-step rule, but we don't know yet. Let's just test out the one-step rules to see if any of them work. These both worked for 1 to 20. Let's try for 4 to 80. And if you try 4 plus 19, that's only 23. So you know that the plus 19 rule is wrong. It has to work for all x to y's. So let's try the times 20 rule. 4 times 20 is 80, so that did work. So 1 times 20 worked, 4 times 20 worked, 7 times 20 worked, 10 times 20 will work, and so will 13 times 20. So that means our rule to go from x to y is going to be x times 20 equals y. Going down into our answer choices, we have to take a look at which of these fit that rule. So if our x is 15, and we see that all our x values are 15 here, we need to apply the pattern rule to 15. So 15 times 20 gets us 300. So I'm going to just cross that out so we don't think that's part of the x. So which of those answer choices goes from 15 to 300? That's going to be this choice where it just says 15, 300. Question 4. Renting a boat for 2 hours costs $14, while 3 hours costs $21. Which coordinate plane correctly graphs the ordered pair that corresponds to this relationship? Make a table to figure out which coordinate plane grid matches your table. We can see here that there is a very clear pattern in our hours, and if we look at the tables of our graphs, if we look at the graphs, we see that our x-axis is time and our y-axis is the cost. So we know that all these hours represent the x values and all these costs represent the y values. So our very first ordered pair is going to be 0, 0, because when you rent for 0 hours, you should pay $0. That makes sense. We have 1, 7, 2, 14, and 3, 21. And if I continue this trend, I can see x is going up by 1, and then y's are going up by 7. So I can safely assume that 0, 1, 2, 3 will become a 4, and then a 5. And I can also see that it goes 0, 7, 14, 21, 28, 35, because I'm just counting by 7s. Now I'm going to go look for a table that works for a graph that works for this. Let me get that out of the way. So 0, 0, 1, 7. Well, this does look like 1, 7. Hold on, let me put this back in. 4, 28, 5, 35. So 1, 7 looks about right. What about 2, 14? This looks like it is 2, 14. 3, 21, 3, 21. This is about 21. And then 4, 28. We have 4, 28. This does look like it's about 28. 5 will go all the way up there. 35. It is at 535. So I know that this answer is probably correct. I'm going to go ahead and check the other tables just in case. Not tables, sorry. The other graphs just in case I made a mistake. And if I look over here, I see that the first one at 1, 7, it's sitting at 1, about 14. And then 2, 14 is there. And then we have 3, 21, but it's sitting at 3, 21. 4, 28 is sitting at 4, 21. So I know that's not the right answer. That is not the correct graph. If we move to the next answer choice, we see that it sits at 1, 5, 2, 10, 3, 15, 4, 20, and then 5, 25. And that's not right either. And then our last one, the very first one, sits at 0, about 7 or 8. So 0, 7. We don't have anything that corresponds to 0, 7, nor do we have anything that corresponds to like 2, 3. So we know that that choice is also wrong. So the correct choice for this one is going to be our first answer right here. Question 5. This table shows the first 7 terms in 2 number patterns. Which statement explains the relationship between pattern 1 and pattern 2? Well, let's go ahead and define those relationships. So in order to go from pattern 1 to pattern 2, so we're going to write pattern 1 to pattern 2. And if you want to make your life a little bit easier, you can just call this x and call this one y. And we could just write, instead of pattern 1 to 2, we just write x to y. So to go from x to y, we're going from 10 to 5. And the first option I see is going to be minus 5, or maybe divided by 2. And then remember, we have to test it for the other one as well. The next term is 20 to 10. Well, 20 minus 5 doesn't get us 10, it only gets us 15. So we know that the minus 5 is wrong. That one's not going to work. Now we can try it with the divided by 2. Well, 20 divided by 2 is 10, so that does work. So we know the rule for going from x to y is going to be divided by 2. And then if we want to define the other way, the y to x, the opposite of x to y, we do the opposite pattern. So if we know that x to y's pattern is divided by 2, the opposite of a divided by 2 for y to x is times 2. So we were able to figure out the rule for moving from x to y and y to x. Now we have to look at the answer choices and see which one of those is going to work. The terms in pattern 1 are 5 more than the corresponding terms in pattern 2. So is 10 5 more than 5? It is. But is 25 more than 10? It's not. So right off the bat, we see that doesn't work. That's not the correct pattern. The terms in pattern 2 are 5 less than the terms in pattern 1. So is 5 less than 10? It is. That works. Is 10 5 less than 20? It's not. So that one doesn't work. So we know that both these answer choices are wrong so far. Over here we have the terms in pattern 2 are 2 times the corresponding terms in pattern 1. So is 5 2 times bigger than 10? It is not. So right away that one did not work because 5 is not 2 times bigger than 10. The terms in pattern 1 are 2 times the terms in pattern 2. Is 10 2 times 5? It is. So this time it did work for the very first one. So we can move on to the next one. 20 is 22 times 10? It is. Is 32 times 15? It is. And is 42 times 20? It is. And we can see that this is going to be a pretty consistent thing. 25 times 2 is 50, 30 times 2 is 60, 35 times 2 is 70. So we know that the correct answer is our last choice. The terms in pattern 1 are 2 times the corresponding terms in pattern 2. We're on number 6 now. This rule and table describes the relationship between x and y. To find y, subtract 2 from x. Which graph shows this relationship? We want to go ahead and write this into our ordered pair. If you have it vertically like this, you can save yourself a little bit of time and just put parentheses and a comma in between the values. And I'll just write it on the side. So this will be 3, 1. This will be 4, 2, 5, 3, 6, 4. And I made the same mistake as I did before. I should have wrote them on the side over here just so I can scroll around. So I'm going to rewrite them real quick. So we have 4, 5, 3, and then 6, 4. So let me get this out of the way and clear it up so we can see our graphs. Over here we have to check that our coordinate plane matches this answer. So at 3, 1, did we have a coordinate? We did. 3, 1. At 4, 2, we got another one. At 5, 3, we got it. And then 6, 4. So I'm thinking that this might be the correct choice. I'm going to check the other graph to make sure that's not wrong. Let me erase these dots. Here we have 3, 1, but this is at 3, 0. This is at 4, 1, 5, 2, and 6, 3, which is not what our information is telling us. So we know that choice is wrong. So our very first graph was the correct answer. And then question 7. During a long road trip, Sophia and her sisters made a game of spotting signs along the road. This graph shows the kinds of signs Sophia saw during the first hour. So we have to make a note that this is something with the first hour. Let me redo that line. First hour. In the second hour, Sophia saw twice as many signs as she saw in the first hour. How many signs did she see in the second hour? Well, if in the very first hour, this is all the signs she saw, we kind of want to figure out how many signs she saw. So she saw 6 rest stop signs, 12 billboard signs, and then she saw 8 speed limit signs. So altogether, she saw 12 plus 8 plus 6 signs in the first hour, which is going to be 26 signs in the first hour. And in the second hour, we know that she saw twice as many. So I can do 26 times 2, and that's going to give us 52. And remember, if you're not comfortable doubling with a times 2, you can always just add the same number. You could do 26 plus 26 instead, and that'll still get you 52. So our answer is 52. Question 8. Look at this pictograph. These show the kilometers run by Owen, Dwayne, and Luke. And then we know that each of these little people is 5 kilometers. How many kilometers did Luke run? Well, Luke has 1, 2, 3, 4, 5, 6, 7, 8 little people. And if we know each of them is worth 5, that means I have 8 groups of 5, or 8 times 5, which is going to be 40 kilometers. So our answer is going to be 40 here. Question 9. Students in Mrs. Clayton's class rolled a 6-sided die and recorded the results. How many students rolled a number less than 5? Well, if we're looking for numbers less than 5, that means we don't count the 6's because 6 is not less than 5. We also won't count the 5's because 5 is not less than 5. It's equal to 5. So now I need to go ahead and add up all these x's or just count them. So in the 2's, we have 1, 2, 3, 4, 5 x's. And using that, I can kind of check how many more the 3's are. And there's just one more, so we know that there's 6 x's, 6 kids who rolled 3's. And using that, I can figure out how many 4's there are. There's going to be 1, 2, 3, 4 more, so that's going to be 10. And then we see here that 0 kids rolled 1's. So we have 10 plus 6 plus 5, and that's going to give us 21 students who rolled less than 5. And then question 10. Which number is missing from this sequence? Well, let's figure out what our pattern is. To go from, we can't go from here to here because we don't know what that initial value is. So we're going to try the next one. To get to 34 to 26, I see that it's going to be minus 8. And that's the only pattern that really comes to mind right away. And then to get from 26 to 18, I see that the minus 8 works there. The minus 8 is going to work there again. And then 10 to 2, it's going to work again. So I know going from left to right, it's going to be minus 8. Well, I don't know what this one is, but I can go from right to left. And since right to left is the opposite of left to right, I'm going to do the opposite of the minus 8, which is going to be plus 8. So going from right to left, we're going to add 8. Going from left to right, we're going to take away 8. So 34 plus 8 is going to be 42. And that's going to be our answer.